We're going to continue now with something called exponential growth functions. Right now, when you think of the word growth, what are you really thinking about, right? Now, I know you're probably saying like to grow, that's true, but without using the same word in the definition, we could say like to uh, make bigger, all right, to enlarge, to increase in size, right? But yeah, pretty much yeah, to grow. So in this one, it says now, which of the following represents an exponential growth function? Now, there are two ways that a function can grow. Okay, the first thing is that our initial value, the a, right, has to be bigger than 1. Okay, so a, we're going to say bigger than 1. All right. So that's like, for example, 2 times 3 to the x. So far, they've all been written like this. And I'm going to start off with like this. So far, we've been dealing with y equals 5 to the x, which is the same as y equals 1 times 5 to the x. These are both the exact same things. Okay, because anything multiplied by 1 will just give you itself again. Another way that you can increase it is, and this is like the most popular way really, is to increase this guy, our growth rate. So b should be greater than 1. That's for things like y equals 3 to the x. Okay, y equals 5 to the x. Any of these things, as long as they're greater than 1. The reason being is because let's take a look at something that is not greater than 1 or equal to 1. So let's say we have 3 times 1 to the x. And let's say that we want to know when x is equal to 0, x is equal to 1, x is equal to 2. All right? If I did this here, we would have 3 times, okay, 1 to the 0. Well, we know that anything raised to the 0th power is just 1. So this whole thing is 1. 1 times 3 is 3, which gives us 3. Okay. What about now if we substituted in this x equals 1? So 3 times 1 to the first power. Okay, all we're doing is just substituting every value here for x. So 1 to the first power is 1. 1 times 3 gives you 3. No growth. Okay, y equals 3 times 1 to the second power, right? 1 to the second power is 1 times 1, which is 1, and then 1 times 3 gives you 3. So there's no growth occurring here. Okay, that's why this number right here has to be greater than 1. And we've been working with all exponential functions that have been greater than 1, like in this one right here. Okay, and so now which of these followings would have that? So let's see. So we know that either a has to be greater than 1 and b has to be greater than 1. So here, okay, our a value is definitely greater than 1, but our b value, okay, 0.25 is actually the same thing as 1/4, and 1/4 is not greater than 1, so this would not be it. Okay, here our a value is less than 1. Okay, it's not less than, it's not greater than 1 over here, but our b value, the main one, okay, this is 5.25, which is definitely bigger than 1, so this is an option. Okay, here we have a negative in the front, not going to work. And then here another negative in the front, so this is not going to work. If it's a negative, it's actually not a growth, but it would be the opposite there. And what do you think that would be? Okay, because there will be another lesson on that. So our only option would be 2. All right. So moving into like more conceptual word problems, this is saying that scientists are studying a specific group of 6 penguins. Just imagine 6 little baby penguins walking around. The population of this type of penguin increases at an exponential rate. So I would probably circle this, okay, of 24.5% per year. So it's increasing. That's how you know. The increasing part tells you it's growth, and exponential tells us that we're going to be working with an exponential function, which is a times b to the x. All right. What function can be used to find the number of penguins after x years? So we know that x is going to be the number of years, okay? And actually what I should really write that is, I should really write that here. This is the number of years, okay? This is going to be the total, right? The total number of penguins. That's usually what, like the whole total is always on this side. And the A represents the initial amount. In this case, what is our initial amount? That's how many penguins we start off with, which is 6. And our growth rate, or our base, this is the amount that we're growing by. So we're growing by 24.5%. That looks like 29. Oops. Okay, 24.5%. So the main thing that we have to do here is, it's a little bit different, okay? We think of everything starting off at 100. Okay, that's how I think of everything. So think about everything starting off at 100%. Right? No matter what you do, you're just giving 100%. Okay. Now to grow, if we're increasing this by 24.5%. So if we're at 100% right now, okay, and we're growing by 24.5%, that means every year we are increasing by 124.5%. Okay, that's our growth rate. Our B would be 124.5%. But when you're writing a function, you cannot have this percent sign, right? This needs to be gone with. So how do you convert 124.5% to a decimal? Well, the way to do that is you go to where the decimal is, and when you go converting from percent to decimal, you go back 2 spaces. So that's 1, 2. So this becomes 1 point. Okay, so I'm just moving the decimal, 245. And this is going to be our B value, our growth. Okay, so in our equation, we're going to have y equals A, that's the amount that we start off with, that's our 6 penguins, 6 times, okay, I'm going to put this in parentheses so that people don't think that it's like a decimal there. This is 6 times our B value, which is 1.245 raised to the x power. Okay, so the initial amount, the amount that we're growing by, any amount that's more than 1 is known as a growth. So let's say that we have something that looks like this, right? So we have y equals, I don't know, let's make up a number, 41.35. Okay, this number, if it's greater than 1, it's a growth. If we have something that looks like this now, 0.75, if this number is less than 1, okay, that's less than sign, this is called a decay. It's decreasing. So here, this is our growth, 1.245%. Okay, I'm sorry, 1.245, which is 124.5%. So this is the exponential function that's going to model this. All right, let me see if we have time for one more. All right, this one says now a home's value increases at an average rate. Okay, so it's increasing. Again, these are the words that you really want to circle right here. Increases at an average rate of 4.75% each year. Now, I know I haven't mentioned this yet, but generally speaking, whenever you're dealing with percents, you're dealing with exponential functions. Anything dealing with a percent, exponential function. Okay, the current value is $350,000. Write a function that can be used to find the value of the home after X years. Okay, so I want you to analyze this because word problems is usually the hardest, right? How do we know if it's an exponential or a linear? Well, linear goes up by the same amount by adding or subtracting, right? Exponential, usually if we see a percentage, will mean that. So we can start off by writing the equation or the general formula for an exponential. Okay, now from there, okay, I'm gonna go down and I'm gonna drop down the y and I'm going to drop down this little x here, okay? So x represents the home's value. I'm sorry, x represents the number of years, and this represents the home's value. And what I'm actually going to do is, just to save some space here, I'm just going to just write that down. So this represents, let me just go back and get my pen. This represents the number of years, okay? Remember, x is usually, and I'm going to take away the word usually. X is always time, some kind of time. Y, okay, is the total, but total what though? Okay, total value of the house, because that's what we're talking about here. We're talking about a house's value. The total value of the house after how many years? After x, because we don't know what x is yet. After x years. Okay, a is going to be the initial value. Okay, notice that stays the same. This is going to be our base, or our growth rate. How much is it growing by? Okay, and once you've pulled together these pieces, that's all you really need to know. And it's really honestly just the a and the b that you need to know. So let's pull out here to decide. What is our initial value? It says that the current value is 350,000. Okay, so then the growth amount, how much is it growing by? Well, it's increasing by 4.75, so 4.75. Now this is 4.75%. You have to always convert this percent to a decimal, and you can convert 4.75% by taking this decimal and moving it to the left once, twice. Okay, so that's where my decimal goes. Now notice that there isn't a number there, so I'm going to fill that space with a 0. So my b value ends up being 0.0475. Okay, so our equation now is going to be y equals 350,000. Okay, now the b isn't just this piece. Okay, this is what we're growing by. So we're gonna go ahead and we're gonna add a 1 to this. And you know what, I kind of messed up, because from the last question that I said, what I really meant to say was this. I'm just gonna go ahead and just backtrack. I'm sorry. So it's not gonna change the answer too much. But you remember how I said that everything started off at 100%? Okay, and then we're adding on this 4.75%. That means that we're essentially increasing by 104.75%. All right, now that is what you're going to convert. So 104.75%, you're going to take this, move back twice, and it becomes 1.0475. So that's going to be our b, 1.0475 raised to the x, right? And this is what our exponential function is going to look like. And then after that now, okay, how much will the house be worth in 10 years? Well, which variable, y, a, b, or x, represented years? X in this case represented years, so our x is 10, meaning that we just have to go back and just substitute this. So y is equal to 350,000. Okay, keeping everything here, except that instead of an x, we're just going to put a 10 there. Right, now at this point you're going to definitely have to use a calculator of some sort. I'm going to go ahead and see if I can just pull this up right here, get a little smaller, and we'll just substitute this here. So we have 350,000, okay, open parentheses, 1.0475. This little hat button, this as upwards arrow, means raising to the 10th power, and we get that the house is going to be worth 556,653. So 556,600, and I forgot the rest, 683 in 10 years. That's a pretty big jump, considering that right now it's only 350, and if they wait 10 years, it'll be worth $556,000. That's a huge amount. Okay, so this is how we deal with some word problems about exponential growth.